Okay, so we've just done quiz 3. We'll certainly have more quizzes to come in the future, so if things didn't go your way on this one, just know that you'll get another shot soon. One important announcement, homework 9, if you look at the course schedule that I provided at the beginning of the semester, that indicated that assignment would be due on Thursday of this week, but I'm going to push the due date back to Friday at 5 p.m. So that'll give us some time on Thursday's class to talk about a few more ideas that are included on the assignment. So ordinarily your assignments are due before class on Tuesday or Thursdays. This one's due by 5 o'clock on Friday. Okay, what we're going to talk about today is incremental rate of return. Can anybody define this word for me, incremental, or explain what it means? If somebody said, oh, he's making incremental progress, and that would be an example of that word being used in a phrase. Yeah, go ahead.
It would be like a little bit over time.
Okay, good. Yeah, a little bit over time. So in the same way, it means like from one step to the next. So what we're going to talk about today is a way of using rate of return to compare alternatives. Now we can always use external rate of return to compare alternatives, but remember, internal rate of return we had to be a little bit more careful about. So this is a way of, with a twist, using internal rate of return to compare alternatives. So incremental cash flow means the difference from one alternative to the next. So what you do is for every year in a cash flow diagram, if you have two options, you find the difference between the two. So let's say, for instance, that we have option B that's $60,000 as a first cost and option A, which is a little bit cheaper at $40,000. The incremental cost is the difference between the two. So if we do B minus A, you can see that the difference between the two options, it's an additional $20,000 investment. So the reason why we do this incremental analysis is the main question we're trying to answer is this. Is it worth spending the extra money? Like when you're comparing option B and option A, assuming that they're both acceptable, and so you've done that pre-screening. You know, the pre-screening is the internal rate of return greater than the MAR? So if both of them get the thumbs up on that initial screening, then the question is it worth buying the more expensive item? And according to economic analysis, the reason why you'd buy the more expensive item is if it's returning more than the increment in cost in terms of benefits. So, you know, are you getting more revenue than the cost on that increment? So here in this illustration, what it's showing is that the annual cost of B versus A, you can see it looks like maybe the reason why B is more expensive is it costs less to operate on an annual basis. Instead of $25,000 each year, option B only costs $19,000 per year to operate. So, you know, some people drive around in hybrid cars, and a hybrid car is a little bit more expensive than a normal internal combustion vehicle. And people who buy the hybrid car, they're thinking, well, I'll pay a little bit more up front, and then I'll save money on fuel through the entire life of the vehicle. And so that's just kind of a real-world illustration of how people do incremental analysis sometimes without really even thinking about it. Now back to this option, B versus A, you'll notice that option B also has a higher salvage value. So what we'd have to know in order to determine whether B or A is better is we'd have to know what's the interest rate, and then also how long is this equipment lasting. So we don't yet know whether or not B is better or A is better. But what this illustrates is the incremental cash flow. So it's the difference between the two. Now it's no coincidence here that what we did was we ordered on the left side was the cheapest option, and on the right side was the more expensive option. When we're doing our incremental analysis, just to make things simpler, it makes sense to order the options in terms of cheapest on the left and increasing amounts as you move towards the right. So any questions about what we mean by incremental cash flow? Just to reiterate, what's the purpose of this analysis? Why are we comparing the increment of two options. Yeah, it's to see which one's better. If you don't know the answer to a question this semester, that answer is probably going to be right about half the time, to see which one's better. You know, like I keep repeating over and over that this class is just all about decision making, comparing alternatives. So why do we do a certain thing? That's to see which one is better. Okay. So let's look at some of the theory here. We've got two options, option A and option B. And first of all, you can see that of these two options, option A has the higher internal rate of return. So the internal rate of return for option A is 17.3%. The internal rate of return of option B is 16.3%. Why is it that on this figure, this curve is crossing the horizontal axis down here? Like, why do we call this intersection point with the horizontal axis the internal rate of return? Do you remember what the definition of internal rate of return is and why it would maybe be here as the intercept with the horizontal axis? Exactly right. Yeah, so he's remembering the internal rate of return. One of the ways that we define that is equilibrium or balance between the inflows and the outflows. Okay, so when the inflows and the outflows are equal, meaning look at this vertical axis says present worth. So if present worth is 0, internal rate of return is the one where the present worth of the inflows has been discounted at some amount that makes it in equilibrium with the present worth of the outflows. Okay, so the internal rate of returns, A is bigger than B. But let's apply some decision making here. What if your MAR is 10%? Which option should you select if your MAR is 10%? You said it's option B. Why is option B better if our MAR is 10%? Because your present worth is what? It's higher, right. So remember, what we want to do is maximize our profits. It's not necessarily to maximize internal rate of return, but we want to maximize profits. So if our minimum acceptable rate of return is 10%, what that might mean is that's how much we had to pay to borrow the money for the project. So at 10% interest, we're paying off our loan, and then the present value of all the leftover profits is $10,131 for option B, $9,738 for option A. So option B is the more attractive option. So why is it that option A had the higher internal rate of return? How can that discrepancy exist, that I just said option B is better, and yet option A is the one with the highest internal rate of return? We looked at this in class last week, like comparing which one is better versus which one has the higher internal rate of return. So why can the discrepancy exist?
Because you have less going into option A.
Because you have less going into option A. Yeah, so option A has a lower initial cost, and so you're earning a higher percentage rate of return, but since option B was a bigger investment, then you're making more overall. And so you may remember that I showed like two different bank account options. One that was saying, we'll pay you 5% interest, but you're only allowed to put in $5,000. And then there was another account that was saying, we'll pay you 1.8% interest, and you can put in $250,000. So the account that's going to give you more profit isn't necessarily the one that's offering higher interest rate if they have this tiny little amount that you can invest at that interest rate. So in this case, option A has the higher percentage, but option B is more profit overall because it can take a larger investment. Now, what we look at in this graph, what it says is, you know, we could graph the present worth for a lot of different interest rates. we could discount all of the cash flow at 10%, and these would be the present values. We can discount it at other interest rates, and this curve represents what would be the present value at a lot of different interest rates. So eventually, option A goes ahead of option B, but the crossover point is the incremental internal rate of return. So for decision making, what you should be asking isn't which project has the highest internal rate of return. The internal rate of return you can use for initial screening. But if you want to use this idea for decision making, then what you need to analyze is the difference between the two options. So the question for decision making should be, is the additional investment amount yielding more than the MAR? In other words, what if you could borrow money at 10% and then put it into a different account that's paying interest and it pays 12%? Should you do it? Should you borrow money from one bank at 10 and put it in another bank that pays 12? Definitely, because then you get to keep the difference between the two. So as long as you can make more than your minimum acceptable rate of return, you should always go with the more expensive option. So as a reminder, when you're comparing projects, the future value should be discounted at the MAR, not at the internal rate of return. So that's just a warning, because the in-class activity we're going to do today, sometimes students get confused about that. We'll calculate the IRR for initial screening, but then when you're finding the present worths, then you use the MAR, not the IRR. Okay, so let's walk through what is an incremental analysis. Let's say we're comparing two different alternatives. We're told what the MAR is, 10%. We know all the different years. We have option A on the left because it's cheaper. We have option B on the right. It's more expensive. And it looks like the reason why it's more expensive is that it generates more revenue each year. Option A only generates $22,000 of revenue, but option B generates $26,225. So the question is, should we pay more up front in order to get a larger annual amount each year? And the way we can answer that question is by calculating the increment. So the incremental cost is $13,000. The incremental increase in revenue, $4,225. So you can figure out which option is better by the present worth method. The present worth method will always tell you which one is better, but it won't always tell you what is the rate of return on the difference between two alternatives. And in this case, that's what we want to know. We want to know for that extra $13,000, what is the rate of return on the increment? The increment is the difference between the two. So the rate of return on the increment, what we do is we just do the IRR function equals IRR, highlight the cash flow, and it tells us that the internal rate of return on the increment is 11.4%. So we should do that. We should go with option B, because our decision criteria is if the incremental internal rate of return is greater than the MAR, then choose the more expensive option. So I'm going to write that on the board so you can copy it into your notes. So the criteria is if delta IRR is greater than MARR, then select the more expensive alternative. So that's the criteria. Why? Why should you do that? It's going to give you the most profit. Very good. So you choose the most expensive alternative in this case because you're getting more than you're paying. Because the rate of return is greater than the minimum, and you want to maximize your profits, and so it's the better alternative. And so this is the confirmation that option B is better. It's because option B has the highest present worth, and the rate of return on the increment, remember, increment means difference between the two. the rate of return on the increment is greater than the MAR. Okay, so incremental analysis really isn't that complicated. It's definitely simpler than external rate of return. Sometimes things get a little bit more complicated when you have lots of options. And so that's what we're going to look at next is, let's say you have several options. The order that you do the comparison can sometimes throw students off. So if the internal rate of return of the difference is greater than the MAR, then the additional investment is justified. That's just another way of stating the criteria that I wrote up here on the board. Any questions so far before we look at an alternative with several options? Yeah.
Okay, so we're able to compare the internal rate of return to different initial values because of the.
I'm sorry, what's that?
We're able to compare these two values that there's two different initial values. So we're able to compare the internal rate of return because we're going through the different.
When you say there's two different values, you mean of the present values? The reason, so the rule was before, don't compare internal rates of return to each other, right? But this internal rate of return is just for a single cash flow diagram. And so it's not like you're comparing this percentage to a different internal rate of return. You're comparing it to the minimum. And so it's a thumbs up, thumbs down. And remember, how do we use this initial IRR? You compare it to the MAR, and if it's higher than the MAR, then that means it's acceptable. If it's less, that means it's unacceptable. So essentially what we're doing is, by looking at the increment, we're giving a thumbs up or a thumbs down to the increment. We're saying whether it's an acceptable increment or an unacceptable increment. And so here, this 13,000, it's all we're focusing on is the difference between the two. We already established that they were both acceptable options, and so either option B or option A will give us profit. But we want to know how much extra profit, like on a percentage basis, B gives us. And so, the rule is we are allowed to give a thumbs up or a thumbs down on IRR, not comparing it to other IRRs, but just an acceptable or unacceptable. And I think the next example will highlight that even more, like how we use this incremental IRR, because we have more options. So before we get to that one, let's just go over some terminology, because the letter I is really being used quite a lot by your textbook. And so I just wanted to put all of the various definitions for I and how that's used into one spot. Okay, so first of all, a capital I means interest. Of course, we all remember that interest is the actual amount that you get paid over time for the usage of money. The lowercase I is where we're expressing that as a rate. So it is an amount per time as a percentage of the original amount. Okay, now I star means rate of return. And so that is when we've done the unrecovered balance type analysis. And one type of rate of return is the internal rate of return, and that's where you assume that the earnings can be reinvested. That's where you assume that there's going to be balance between the inflows and the outflows. Okay, so I star means rate of return. I prime is the variable that is often used in external rate of return problems. And that's the overall rate of return that takes into account the external reinvestment rate as well as the rate that the cash is generated by the project itself. So one of the factors that goes into I prime is I sub I. That's the external reinvestment rate that's usually just given to you. That's the rate that the money that's generated earns once it's put into a secondary account. And finally, what we're talking about today is delta I star. So it's the incremental internal rate of return. So it's a lot of different variables to keep track of. And so you've got that slide in the notes. Are there any questions about these different types of interest rate? Okay, so what we're focusing on today is delta I star. And remember, the rule is if the if the incremental internal rate of return is greater than the MAR, then the increment is justified. The extra amount is worthwhile. Okay, so this one's complicated. We're going to go through it slowly because it's important. This is the type of problem that you'll see on an exam and in the homework. In this case, we've got 5 options, A, B, C, D, and E. You can see that the MAR is 18%. And these have been ordered in terms of cheapest to most expensive. If you're given a problem where that's not the case, you should reorder the columns in your spreadsheet so that it is cheapest on the left, most expensive on the right, and increasing amount in between. Okay, so the first comparison that we're going to do is we're going to do B versus A. And so you can see we have the incremental cost, 12,000, the incremental benefit, 3,100. And so we just do the IRR function on this cash flow diagram. And so the incremental internal rate of return is 22. And then the statement of whether it's more or less than the MAR. So that's more than the MAR. And what it means is do B instead of A. Because the more expensive alternative here, B, that extra $12,000 that you'd spend is worthwhile because that extra $12,000 is earning a rate of return of 22% on the increment. And so do B. Now what you'll notice is that now our next comparison where we're going to look at C, whether C is justified, because you'll notice that option C costs an extra $5,000. Now we're comparing it against B. So A is out of the running. We already decided that B was better than A. So A is out of the running. So the next comparison is C versus B. And so we found the incremental benefit, the incremental cost, and the rate of return there on the difference is 43%. So that looks pretty good. That's more than the MAR. So now we're going to do C. So the next comparison is D versus C. Because we've already sort of, at this point, C is the champion in our eyes. Now the thing of it, though, is that for option D, the incremental internal rate of return is 0. So that's less than the MAR, and that means that we have to stick with option C. So option D is more expensive, but it's not worthwhile. So our last comparison, you'll know it's not E versus D, because we rejected D already. So you're always comparing the most expensive option, the next one in the list, to whatever was previously like the champion of all your alternatives. And so this last comparison is not E versus D because D was rejected. Instead, the last one is E versus C. Now, I guess probably to be really sure that all of these were okay, what we should have done was calculated the internal rate of return of each of them to do an initial screening. And that's what I'll ask you to do on today's in-class exercise is start with an initial screening of all the options, give them a thumbs up or a thumbs down, and then do the incremental analysis. The principle here is that you should continue to choose the most expensive option as long as the increment will be greater than the minimum acceptable rate of return. So spend every extra dollar that'll bring a return greater than the MAR. Okay, so here's what we're looking at. We've got 6 different types of asphalt compactors made from a variety of different manufacturers. And what you'll need to do is set up a spreadsheet similar to the one that we saw on the previous page. So I'll bring up that previous example so that you can use that as a reminder. Now, I've given it to you. It's scrambled. The order is scrambled. So you need to sort it in terms of cheapest on the left, most expensive on the right, and go through these steps, A, B, C, D, and also you're going to need to fill in the blanks on the table there. So tell me what is the internal rate of return of each, and whether it should be accepted or rejected. Now this cash flow, each one of them we're going to assume lasts for 10 years and has 0 salvage. And you can see in the handout it says that the MAR is 12%. Okay, so from beginning to end, we start off with this unknown, this unknown analysis we have to do here. We've got 6 different options of equipment. We're going to have to sort it from cheapest to more expensive. And so that was the first thing that I did here, is I put the Deere first, then Komatsu, then Cat, Hitachi, Volvo, Atlas. And so it's in order of cheapest on the left, gradually increasing in expense. We'll do the initial screening, so that's the internal rate of return, IRR, and what we're looking to see is whether it's higher or lower than the MAR. So the MAR is 12%, so that allows us to, right off the bat, reject the Komatsu. It's going to be unacceptable. So when we do the incremental analysis, we don't have to include Komatsu in any of the comparisons. So you can see down here under initial screening, I say acceptable or reject for each of the alternatives. Okay, so the first incremental is going to be the Cat minus the Deere. And so the incremental cost, $25,700. The incremental addition in revenue, $4,400. So the incremental internal rate of return is less than 12%. It's only 11.2. So that tells us it's not worth spending the extra amount to get the Cat. So Deere is still the champion at this point. It's the best option that we've got. So then the Hitachi versus Deere comparison, we do that. You can see the internal rate of return on the increment is 18.6. Since that's greater than the MAR, we accept the Hitachi. And so Hitachi is now the best alternative. The second best alternative was the last one that was acceptable. So that was Deere. So right now we're accept Hitachi. We have to compare it to Volvo. So Volvo minus Hitachi. The internal rate of return here is negative. So that means actually you're spending more than you're ever getting back to do the Volvo. So we reject Volvo. And last comparison is not Atlas versus Volvo, because Volvo was just rejected. So it's Atlas versus Hitachi. You're always comparing the options versus whatever was the best option to date. And so once we get to the Atlas, the best one that was acceptable up to that point was Hitachi. So the last one, Atlas versus Hitachi, you can see the incremental internal rate of return is less than the MAR, so we reject Atlas as well. And so therefore, Hitachi is the best option according to our incremental analysis. The rate of return on the increment is 18.6%. That's the interest that we make on the additional amount, on the difference between the two, which was $33,000. And then we just want to double check that Hitachi is the best by calculating the net present value of each. And so you remember the formula for that is inside of NPV, you only put numbers that are in the future. So these year zero amounts have to be added outside of the NPV function to get the correct amount. So the NPV for each of them shows us that Hitachi is going to generate the most profits. So that's how we can use the incremental internal rate of return. It can tell you which one is best, and more specifically, it tells you what is the rate of return on the additional amount required for more expensive alternatives. Okay, that's all I have for you today. Remember, as far as our announcements go, that the next homework assignment that you've got due is pushed back to Friday. That doesn't mean delay. Actually, my suggestion is get started on the homework as soon as possible while this is still kind of fresh in your mind. And to that end, I'd recommend that you save your file so you have access to this later on when you're working on the homework assignment. So that's it for today. I'll see you on Thursday.